Students, welcome back to Stanford Code and Place 2023. This is week 3. We have spent the first 2 weeks learning about Carol, which is our little robot that we could move around the screen and he could pick up a beeper here and put a beeper there. And it's been great, but if you didn't like him so much, hey, you don't have to worry about him because we're moving on. And if you did like him, well, you can always go and visit him, but we are moving on. This week, we're going to be starting what are called console programs, which means they input and output onto the old-fashioned console, which in the old days was like a typewriter, and then in my days it was just the screen of green or orange characters. That's where we did all our work, and now it's just this antiquated idea that there's a console. So let's jump into my weekly cheat sheet. This week I have given you a couple links. The problem that we're going to be dealing with this week is called Mars weight. Another problem that we're going to be trying to attempt to get to is called planetary weight, which is just an extension of Mars weight. And then I've linked in lesson 5, which is about expressions. I love that phrase. I thought there would be no math involved. That unfortunately the lectures had a lot of math, which I think is completely unnecessary. Most expressions don't involve math, and you don't need to worry about math if that's something that isn't your favorite subject. And then control flow, a lot more of the if loops and while loops, the for loops and while loops that you've learned about. They actually don't play a role in the Mars weight and planetary weight, which is kind of ironic because I really wish they had thrown that in. There are some work problems to deal with it. So normally we would start out by asking each other some interesting information. This week I was going to ask people what your favorite movie is and why. Mine is It's a Wonderful Life, because there's one very special line in the movie, but I can't share that with you on the internet. We'll have to only in person, okay? And then since we don't have that information, I'm going to go ahead and write a program that will kind of walk us through that anyways. And that's going to review print and input, which are things we actually should have looked at last week, but I thought that it was so complicated last week with Carol and the whole fill beepers thing, spread beepers thing, that we just postponed that. So let's take a look at that now. I want to introduce you to a tool that's available on the internet. It's called pythontutor.com. It's a great little site. It's similar to our IDE in that it will step through the code, but it goes one step further in the sense that it also shows you the variables, which is very cool, and especially when you get into data structures and building really complicated data structures and dictionaries and all sorts of things. It's really cool. So I always like to show this to my students. So I wrote a little program here for us. Actually, this is not the program this is the program that I wanted to start out with. This program is going to ask a name, and if the program knows the person's name, it'll tell you their favorite movie. So the point of this is to introduce 2 new functions. One is input. So here's input here, and let's just run it. Okay, let's just run it. So we are going to, let's see, I have to go visualize execution. Okay, so the first step here, enter a name, and I'll see if I know their favorite name. So let's put in Joe, first of all. I submit. Now, look at what happened here. This box here is a variable. It's graphically showing you what a variable is. A variable is a box in memory, and it's got a couple things. One, it's got some data in it, in this case, Joe. And the other thing is it has a type, okay? I wish the types were explicit here, but it's giving you these quotes, which means the type is a string, all right? So the type of is a string, and its name, or here where it says name, that's the variable's name. Maybe I should have used a more descriptive thing. So let's go ahead and step through it. So now it's going to check if the name's equal to Adam. Another thing it's introducing, and this is only being introduced this week, is the double equals sign. So normally in math, when you want to check right equality, you would just say, A equals B, right? And that's a test. Well, I'll just say that in computers, if we want to check if A is equal to B, we write A equals B. The reason why is because the single equals is reserved for assignment. So if I said A1 equals B, it would actually be assigning things. Oh, maybe we could actually do this. What if I go and edit and I don't think I think it's going to give me an error. Yeah, invalid syntax. But let me just do this. Okay, let's keep it equals. But let's put a line here. Name equals Adam. Okay, let's just try that. Visualize. Okay, so input, and I'll say Joe. Now the first thing is that it says the variable is Joe, and I step over this line. Now look, the name is Adam. Okay, so single equals is an assignment. And if you want to get technical, there are what are called R values and L values. And a variable can be an L value in this case, or it can be an R value in this case. R value means it's on the right-hand side, and I can technically flip these around. I could have said Adam equals name, because what's happening here is it's getting the value of name. It's not assigning the value of name. But let's get rid of this line, and let's try to actually execute the code correctly. So I'll put in Joe, and it comes down, it checks if the name Joe is equal to Adam. No. Else if, elif, so that's something new. Else if. In most languages you write out else if, but in Python they wanted to save those 3-4 characters, so they make elif, name equals Meron, so that's not going to work either. So finally, else, print, sorry, I don't know their movie. By the way, I, as a Java and C guy, I can never remember to type in the colons. So it finally crossed my mind to think, why are there colons? Because technically, the language doesn't need the colons. The language can figure this out without the colons. So why do they have these colons? Well, the best answer I could find is that the colons are actually there to help the editor. Because in theory, the editor maybe isn't smart enough to know that after the if statement, it should be indented. The only problem with that theory is that all editors, I think, oh, no, okay, so it's not smart enough. I thought that most editors are smart enough, but no. Okay, so that really is the case for this particular editor, where it's not smart enough to know that after the if statement, it needs to indent. And the rule of thumb, which I never really thought about, but it really is helpful, is whenever there's a colon, that means start indenting code. Whenever there's a colon, indent code. If only the editors also, because a lot of editors out there will go ahead and indent. Well, why doesn't it tell me that I needed a colon, right? It should have done that, but oh well. So what did we learn here? Input, print. I forgot to mention print, but yeah, print is a new function that we should have learned last week. Double equals, that's a new thing this week. Elif and else. And also reviewed colons and why we have colons and some ways that'll help me remember when to use colons. So that's the review from last week for print and input. And it's also helped this week because we wanted to review variable types, int, float, string. Okay, let's work on that int, float, string, okay? Because we talked about strings so far, but we didn't do ints and floats. So I came up with this little program here. And let's just run it and we'll walk through it. Okay, so it's going to print. I will add 2 numbers for you. Step. Input the first integer. So I'll just put in 5, submit. So now we've got number 1, the name of it, the value, 5, and the type. Now you see there's quotes around it. That means that type is actually a string. It's a string. Why isn't it a number? I asked for a number, right? Well, I didn't tell Python I wanted it as a number. Let's go to the next step. Enter a second float. I'm going to put in 5 again. Okay, so now we've got number 2. It's the same thing. It's also a string 5. But now look at this next line. Number 2 equals float number 2. Now again, variables can be accessed. In this case, it's being accessed as a right-hand side value. So it's retrieving the value out of number 2. And then it's going to take the float version of it and then it's going to store it in a number 2. So when I step, watch what happens to number 2 here. It's going to change from that quote 5 quote to 5.0. So that's something new, the float. And so we can cast into different types. It's funny because, there's type casting, but this is good. We're casting into a different type float. All right, the next line is going to take number 1, which is a string, and number 2, which is a float, and it's going to add them. Now you should be curious, how can it add a string and a number? I mean, because if it's a computer, it doesn't really know how to add a string and a number because they're different things, right? Well, let's see what happens. Does it throw an error? Type error, must be stir, not float. There we go. So how can we fix that? Let's go and edit that. So number 1 is a stir, right? So we can convert number 1 equals, oh, you know what? Here, let me show you another way we can do this. Instead of doing it at a separate line, you can also do it right here. Float of input. So now it's going to actually give me a float to start. So I put in 5, and look, now it says 5.0. Okay, then next one is 5. And again, it starts out at a stir, then gets converted to a float. Now it's going to add those two. So result is now 10.0. Now it's going to print. The result is 10.0. By the way, I wanted to introduce another thing, which I don't think they've even taught in class, but it's so useful. I wish they had. You can put multiple arguments into print separated by a comma, and it'll automatically put a space afterwards. It's very helpful. And then finally, if number 1 equals number 2. So let's take a look. Number 1, number 2. Yeah, it looks like that should work. And sure enough, those are the same. And let's just run it again, just to make sure that it wasn't a fluke, because let's give it different numbers. Let's say 1 and 2. And so now it's going to create that, create 3, print the result, and it's not going to print that they're the same. All right, so what did we learn here? We talked about casting into different types. We talked about, so previously we had talked about strings, but now we've talked about integers and floats. We didn't talk too much about ints. I couldn't convert this to an int, but in this case I'm adding an int and a float. Let's see what happens. It's worth checking. We'll take that to an int. Okay, 1. So what happened? You see there's no quotes around there? So now it's an integer. It's not a string. Put 2. But so there's not 0.0, so it's an int. All right, 2.0. And now it did add the 2. Now, again, we think back, it's a computer, it's a dumb computer. It couldn't convert the string to a number, but somehow it's converting the integer to a float. And that's just one of the things that Python does. And certainly not every language does it, but Python does know how to do many conversions. In this case, it's going to convert from number 1 to from an int to a float. All right. So we talked about assigning versus using variables. We talked about casting. We talked about the double equals. Oh, the one thing I didn't talk about is constants. What's a constant? Let's go back to this one here, and let's edit this code. So a constant, in many languages, constants are special things. And the main thing about a constant is you don't want to modify a constant. In most languages, you cannot modify a constant. In Java or C, you declare a variable as a constant. You do not in Python. So I'll create a constant by convention. So this is not a rule, but it's by convention. Everything's going to be uppercase, okay? So let's say number 5 equals 5.0. So what this does is it's just a regular variable. And let's change this from number 2 to number 5. And let's change the print statement to come on, keyboard. Hey, that's 5. Visualize execution. All right, let's start stepping through. Now notice, before we've done anything, it already created numbers as a variable 5.0. So like I was saying, a constant is just any other variable. And don't be doing this, but you can actually change that constant, which is why I don't like constants in Python, because they aren't constants, okay? It's just something they threw in later and not really well enough. So let's go down here. Let's put in 5, because that's going to have to take that test. And we'll put in 5 there. It's going to come down here. It's going to add. It's going to print. Now, if number 1 is equal to 5, yes. Hey, that's 5. Okay. So that's constants. Now, let's tackle Mars weight. So we've learned a bunch of things. Let's see if we can apply it. Mars weight. So what they want to do here is, this is the execution. It's gonna prompt enter a weight on Earth, and we enter the weight. The user enters the weight, and then it's going to print out the equivalent weight on Mars of whatever that conversion is. So let's think first of all, what is necessary? Well, we know that there's going to be some printing here. In fact, it's actually an input, right? There's going to be an input. So let's go ahead and say Earth weight equals input, and let's put this in quotes like that. We know that that's going to have to happen, and we've got an Earth weight. Okay. Now, what's the next thing? It's going to have to print. There's going to have to be some stuff in the middle here, but let's jump to the conclusion based on what we know here. Print the equivalent weight on Mars and we'll do plus sign here to concatenate instead of using the comma, because there's already a space here. I haven't created this variable yet, but let's put Mars weight. So we know that there's going to be an Earth weight. We know there's going to be a Mars weight. The question is, how do we convert? Well, let's read a little bit here. I believe that it should tell us here that Mars weight is 37.8% of their weight on Earth. So wheel should be turning that I need to convert Earth weight to Mars weight. Now, which is going to be on which side? What are we assigning into? Are we signing into Earth weight, or are we signing into Mars weight? Which is the L value, which receives the assignment, and which is the R value, which is we're getting it from? Well, what we're assigning into is going to have to be Mars weight equals Earth weight. And how does the conversion work? It's 37.8%. So I could do 0.378. I mean, that kind of seems like that kind of should have worked. Yeah, let's just try it. Run. Okay, let's put in 120. Ooh, that's a lot of red. What's going on here? Did you mean, this is really cool. They've added a bunch of things here to help diagnose things. And it says, did you mean to multiply a string or a list by an integer? Python allows this, but you cannot multiply a non-integer, and you cannot multiply, or blah, blah, blah. And most of this is for stuff way at the end of the course. But the problem is that we cannot multiply a string times a float. Now, if this were on Python Tutor, we would have seen that when this is returned, it's actually a string. So one thing that we like to do is actually indicate what's type. We're going to call it stir. And we are going to convert that to the float. Okay, so we want to create a variable Earth weight that is a float of Earth weight stir. Well, now remember earlier when I had that program? Let's go take a look at it. Here, we inputted a number, and here's another one. Here, inputted a number, and then we converted it to a float. So we can do that. And I want to give you just one small warning that in other languages, Other languages, you do it like this. That kind of thing, that's a typecasting. So it's endlessly confusing for someone like me. But just so you know, let's go ahead and put earth, weight, stir in there. Now let's see what happens. Oh, you know what? I've got this window is a tad too large for you to see. 120. Okay, we got a little bit better. It's not quite as much errors, but can only concatenate stir, not float to stir. So again, if this was on Python Tutor, we would have seen that Mars weight is a float, and this one here is a stir. So we need to actually convert it to a stir. So similarly, let's assume that we have a Mars weight stir, and we're going to instead, let's just copy and paste it. Mars weight stir, same thing as before, right? What are we going to convert it to? Is it a float again? No, we don't want a float, right? We want a stir of Mars weight. Now let's start writing that. 120. You did it! Good job. All right, let's go back. Let me return back there just for a minute, because let's summarize the problem, right? So what did we learn here? Well, it was just really a review of what we've done so far. So we have input, we have print, we have type conversion, float, and stir. But it kind of is an example to see, you know, why do we need to do those type conversions, and how smart or dumb is Python. Turns out Python isn't super smart. The only one that we've seen it be able to handle is an int to a float, right? There's no conversion between strings and ints, strings and ints or strings and floats. So that is one problem, Mars weight. Let's take a look at the other one, which is planetary weight. So what I'm going to do is I'm going to copy this code here. Oh, I almost forgot. They wanted me to teach you one more thing. Remember constants? Okay. Constants. Let's create Mars conversion equals 0.378. Now we can replace 0.378 with Mars conversion. Now, what is the good of this? Well, we're going to see in just a second. Let's just rerun just to show you this does work. Let's say it's 100 pounds. All right, so let's copy that code. The whole thing. No, I don't want the whole thing, because maybe they have some comments that we want to use. We're going to copy that. We're going to go over to planetary weights, and we're going to put in our code here. So, same thing, weight on Earth, 120, planet Mars, okay? Same thing, except now they want us to do it for any planet. Well, not any, but any of these, this list of planets here. And now you'll get to see why Mars conversion might be useful. Okay, so instead of Mars conversion, we want to be able to check Mercury, Venus, Earth, Jupiter, Saturn, Uranus, Neptune. Okay. So let's think, what do we know and how can we apply it to this situation? So what have you seen so far in this section that could help us figure out which of these planets is the right one? Well, let's think. We had a sample here where I inputted a name, and then if the name matched, we could print different things. Could that be useful? I think maybe so. So that involved if, elif, else, right? So let's try doing some things here. So now we have a new prompt. Enter a planet. So let's say planet stir equals input. And why is it a stir? Because everything from input is a stir. Enter a planet. Now, let's use quizmanship. Everything else had to be converted. Do we need to convert this to something? Well, what are we going to use it for? We are going to use it to compare it to other strings. So actually, we don't need to convert it. But what we need to do now is to figure out which planet it is. So let's start doing, remember how that looked? It was if something, then elif something, then else something. So what are we going to check in here? If. First, we want to check to see which planet it is, right? And so there's a bunch of these planets. So let's just start dropping these. If planet stir, and how do we compare a string? We use the double equal sign. Mercury. Then we've got this Mars conversion here. Let's just call it conversion. And let's now assign conversion equals Mars conversion. elif. What are we going to replace this here? Now we're going to do planet stir equals some other planet. And then we're going to say conversion equals something conversion. Now let me grab some pre-prepared code here just to speed things up. And let's just do that. Okay, gravity. So instead of conversion, we have gravity. Okay, let's copy. How many are there? There are 9 planets, right? 1, 2, 3, 4, 5, 6, 7, 8. Otherwise, the 9th one is going to be what we want. Okay, so now we've got Mercury, Venus. Oh, actually 8 planets. Up. shows you how old I am. Venus. Mercury, Venus, we've already, well, yeah, and we have to do Mars again. Oh, this is Mercury. I thought I'd already done that. Venus, Mars. All right, for consistency, we better use gravity here. All right, Mercury, Venus, Mars. Conversion equals Mars gravity. And you know what? Let's just comment this out for now because I don't want to make a mistake and then realize I had to fix all of these. It's one strategy. So let's just see if it works for Mercury. Run. Okay, unexpected indent. So this is something I didn't even know. When you have your comments in every other language, when you have your comments, it doesn't matter where you put them, but Python wants them at the proper level of indents. So let's, oh, that's not good. Let's reload this page. Okay, let's try running it now. And the sample, well, this is not going to work anyways. 120. Oh, sorry, I just didn't type in the right thing. 120. Mars. Okay. So it did something, so that's good. So what I want to figure out is I would need to finish this up. Okay. Let me pause for a second. Let me finish it up. We'll come back. All right, I've got all these things put in just like the other ones. Let's go ahead and run it. So let's put in 120 and Uranus. Now, it didn't work. And you notice how this thing goes on forever? So this is a good point to illustrate that floating point numbers are represented in the computer imperfectly. So many of you know that when, for example, you divide 2 by 3, it's, 0.6666666 going on forever. And the computer doesn't know how to represent that compactly. So there is a way that Python can do it very inefficiently. But compactly, it doesn't have a way of doing that. It has to approximate it using what are called binary numbers. So we're off by a tiny bit. So there is a way to fix this, and that is to use the trunc function. So we are going to change this, so it's actually round. We're going to round that to 2 decimal places by calling the round function. Whoa. Okay, enter a planet. Something weird happened with the idea there again. Let me reload. Well, the fonts got really big for some reason. Let's try running that. Okay, 100 on Earth and Mars. Okay, so I think the Mars conversion is correct, but let's look at these errors here and see. Incomplete. So Jupiter, the expected output is 354. Our output, oh, the equivalent of weight on Mars. Okay, right, I didn't change that. The equivalent weight on, let's get rid of the Mars, and now we need to put the stir of the planet. Well, we just happen to have that. Isn't that nice? Planet stir. Let's try writing that. Okay, so, I was worried about that. See, there, look, there's no space in between Jupiter and 354. So we have to actually add the space manually. Or we can change this to be comma planet stir, comma Mars weight. All right, now what's it complaining about? The equivalent weight on, we've got a colon. Oh, I forgot about the colon. It's supposed to be Jupiter colon, okay, on plus Jupiter plus, okay, we better do this exactly, colon, the equivalent weight on space Jupiter colon, and then the commas will give us a space. So let's run that. You did it! Okay. So now, what did we learn from all of this? Well, one is there was a lot of copying and pasting in this problem, which is not really the goal, but it is. This is really the current way to have to choose between a bunch of strings. And there are definitely more efficient ways to do this, but this will work for now. But really good practice on elifs. By the way, you don't need the else, but I just took good form to have the else. So round was something new. We did, there's some really intricate work here with the print statement to get the spacing exactly right. We had all these constants here. So yeah, that's pretty much what we wanted to cover. So let's go back and review that we got everything. So we did Mars weight, we did the planetary weight, And I will paste this code in there for everyone to see. But I think we have done it. Congratulations on week 3, and we'll see you next week.